Once again, welcome to MKD Education. Uh, I am your subject expert of engineering mechanics. So today we will discuss about moment of inertia. That this is your chapter 4 of engineering mechanics. We have read about center of gravity. So center of gravity application my moment of inertia ଅଛି. So moment of inertia is very interesting chapter. Exam point of view study aspect from every point of view it is having great importance. So carefully पढ़िबो. So now let's start. What is moment of inertia, right? So friends, moment of inertia पूर्वरु you should know what is inertia. Inertia is an opposition, an opposing property or tendency of an object. गोटे एग्जांपल दोची छोटो एग्जांपल. सपोज गोटे पीस ऑफ पेपर अछि, अनदर पीस ऑफ व्हाट आयरन अछि. यदि पवन आसिला, wind blows, then piece of paper easily can fly away, whereas the piece of iron will be remain there. Reason है the piece of paper is having less mass, so it is having less inertia. Another example. Suppose go a train and a bus, dita like a standing position रे अछि. We want to move both the object, that is train and bus. Definitely bus will require less amount of force to move. That means again bus, if you compare with respect to a train having less mass, so less inertia. Inertia माने केते force रे से oppose करूची. यदि अधिक opposition अछि ताले हमको अधिक force दरकार हो. यदि कम opposition अछि हमको कम force दरकार हो. So obviously bus is offering less resistance. That's why it is having less inertia, right? Similarly, reverse ray, if the bus and train are moving, then we will require more amount of force to train to stop rather than bus. So inertia is also is measured by mass. Mass is the measure of inertia. Inertia suppose mechanics force definition रो तमे पढिसो. Inertia actually Newton's first law दोची. If a body is in rest, it continues to be in rest, and if a body is in motion, it continues to be in motion because of its inertia property. So that inertia will be changed only when you will apply some external force. गोटे मजा कथा कहूची. Suppose गोटे मदुआ, गोटे drunker, से drink करूची because तार inertia ला से drink करिवो. So if you slap him, then that tendency might be changed. Similarly, गोटे object rest रे अछि, motion को जीवा पई हेले you need to apply some force. बा motion रे अछि, rest पणिया को हेले you need to apply some force. So both case रे inertia change होची. Inertia of rest is converted to inertia of motion. In first case, यदि motion रू rest को आसुची, then inertia of motion will be converted to inertia of rest only because of the application of force. So we can say force is changing the inertia of a body. So सेटा हला linear inertia जोठी हमें कहूचे greater amount of mass अछि माने greater amount of inertia अछि. Same thing एठी भी हम apply करिबा. So moment of inertia, for that let us consider an object is moving along a circular path. An object is moving along a circular path, right? So suppose this is the object. So this is the radius of the circular path. The mass of the object, let's say m. It is moving along anti-clockwise direction about this center. Let's say this center is O, right? So let the angular velocity is omega. Angular velocity कौन जानी छो? Angular velocity is the angle turned in unit time. Suppose एटा गोटे बार अछि AB. Suppose A end को हमें रेस्ट रखी कि hinge करी कि B end को turn करूचे, so that it B point comes to B dash. So if this angle theta is the angle of turning, so theta angle is turned in t time, So angular velocity theta by t and torque la omega. Omega equal to theta by t. So say angular velocity iti mass ta move koruchi, right? So here if you consider linear acceleration a, suppose linear acceleration achi, linear acceleration of mass, linear acceleration equal to a. So Newton's law, you know, F equal to ma, Newton's second law. Force kete achi, tangential force. I am talking about tangential force because it is responsible for the rotary motion. So a point re force kete achi, let's say Ft. Ft means tangential force. So this Ft is nothing but mass into acceleration, Newton's second law, as per Newton's second law, right? So again another thing, you know, there is a relation between a and alpha. Alpha kon? Now alpha is your angular acceleration. Angular acceleration and a linear acceleration. So jimiti omega equal to theta by t. So velocity, physics already padhithibo tome, velocity is equal to displacement by time. So angular velocity is angular displacement by time. So you know s equal to r theta. So this is r theta by t or r omega theta by t jagah am put kale omega. So v equal to r omega. Linear velocity equal to radius into angular velocity. Likewise, amar linear acceleration a equal to r into angular acceleration alpha. So this formula will be used here. M a diagram kete likhle na r into alpha. Again alpha is angular acceleration, right? M r alpha. So this is the what? This is the tangential force acting at this point. Now ame jodi moment koiba, actually the body is in rotary motion, that's a moment is responsible for this motion. You know, what a linear force apply kale body re, it will make linear displacement, but we can say force is responsible for linear displacement. And gote object ku ba body ku turn karibe kale we need to apply some moment, turning moment. So iti turning moment kete t, seita hobo kete Ft tangential force Ft into perpendicular distance over जोटा कि radius. So Ft into r and Ft रो value केते ना mr alpha. So mr alpha into r, finally mr square alpha, right? T equal to mr square alpha. Now friends, so ये जो mr square रहिला, mr square को replace करी another symbol I mu lekhuchi, this is I alpha, so that final equation is T equal to I alpha, right? So what is T? T kon? That T hela amara turning moment, ba simply ame koi tara twisting moment also. So T is your turning moment, jo moment jo body ro rotary motion hochi. Alpha angular acceleration. So what is I? This I is nothing but your moment of inertia. Moment of inertia. So why this I is called moment of inertia? There is sufficient justification. Kemiti justify kariba? Now if you consider F equal to ma, so just compare these two equations, F equal to ma and T equal to I alpha. If you compare these two equations, what is F? Force, responsible for linear displacement. What is T? Torque or twisting moment or turning moment, responsible for angular movement, right? So F and T are related. A linear acceleration, alpha angular acceleration. So A and alpha are also related in the same manner, F and T. So जदि F सहित T ର relation अछि, A सहित alpha ର relation अछि, similarly you can say there is a relation between M and I, mass and I, that is moment of inertia. So mass kon? Already mu first to explain karichi, mass is nothing but your inertia. So that's why as F hela linear force, eti angular, eti linear acceleration, eti angular acceleration. So similarly M ta jodi amara linear inertia hela, I habo rotary inertia, or we can say moment of inertia, right? Moment of inertia. That's why moment of inertia is also called rotary inertia, right? So I kete value kete na I equal to mr square. So mass जोटा कि inertia important property, mass into distance of the square of the distance. Distance माने कौन ना जोटी mass रहिला सेठू distance count करिबा about the point or axis about which the mass rotates or turns or tends to turn. So I equal to m r square. So friends, so this moment of inertia is otherwise called rotational inertia. काहेकि जेहेतु inertia mass is the measure of inertia, mass inertia जो गोटे body oppose करूची to remain as it is. जदि rest रची रेस्ट रहिବାକୁ चाहूची जेमति मु कहली गोटे मधुआ से चाहिबो मद पिबा ताकू चेंज करे कहले वी नीड टू अप्लाई एक्सटर्नल फोर्स. सिमिलरली गोटे इनर्शिया कहला माने बॉडी रो केते अपोजिशन अछि, हाउ स्ट्रांग ही इज. सो रोटरी इनर्शिया जोटा रोटेशनल इनर्शिया जोटा हम कहू जे सी भी सेही टाइप रो गोटे अपोजिशन प्रॉपर्टी. केमिति इफ योर बॉडी इज इन रोटरी मोशन देन we need to, suppose we want to stop the body, we have to provide opposing force or opposing inertia force. जो डायरेक्शन रे मोमेंट ऑफ इनर्शिया जो डायरेक्शन रो अछि ताकू अपोज करे कि तार अपोजिट डायरेक्शन में हमहु फोर्स अप्लाई करियो पड़ियो. अनदर थिंग, सपोज तबे साइक्लिंग करछ, साइकिल पेडल बंद कर देला, सो इट विल रन फॉर सम टाइम एंड जदी फ्रिक्शन न थांदा देन द साइकिल वुड रन फॉर infinite period of time because of the inertia. But there is air resistance, there is friction between tire and the road, that's why cycle is stopping after some time. So inertia होची सेटा जहार property tendency to remain as it is, जे जहा से सेमती रहइबो चाहिबो. So गोटे बॉडी जदी रोटेशन करूची it tries to continue its rotary motion because of the property of inertia. So ताकू अपोज करिबा बा ताक आमे बॉडी को रोकिया कहले we need to apply some force but in opposite direction. जदी अधिक इनर्शिया अधिक फोर्स दरकार करिवो काइना से अधिक अमाउंट रो अपोजिशन करिवो बा अपोज करिवो. सो एई जो आई आमे कहले मोमेंट ऑफ इनर्शिया इट इज नथिंग बट rotary inertia, or you can say what the resistance to rotation. काहेकि ना with this much amount of inertia it is resisting. So this is called resistance to rotation by rotary inertia. So I रे value केते ना I equal to m r square. So गोटे ऑब्जेक्ट रो दी प्रकार इनर्शिया थाए जेमि मोमेंट आमे बाहर करथले area into distance, mass into distance. Similarly moment of inertia is also two types. One is mass moment of inertia, another is area moment of inertia. आमे जदि mass into distance रो स्क्वायर होचे that is mass moment of inertia. So instead of mass आमे जदि area नबा that means area into distance रो स्क्वायर, so that will be area moment of inertia. So friends, moment of inertia, rotary inertia or resistance to rotation, right? जदि गोटे बॉडी रोटेशन करूची ताको अपोज से करूची रोटेशन को बंद हेबा पई से कोन करूची रोटेशन केमिति बंद न होबो से इनर्शिया प्रॉपर्टी ही काम करूची बा इनर्शिया जो रोटेशन बंद होनी हमको एक्सटर्नल फोर्स देके एक्सटर्नल टॉर्क देके रोटेशन को बंद करिया पड़ुची. सो अनदर थिंग मोमेंट ऑफ इनर्शिया मिशन दिस इज कॉल्ड आल्सो सेकंड मोमेंट बा मोमेंट ऑफ मोमेंट केमिति होची यू सी मोमेंट कोन ना मोमेंट इज moment of force is force into distance. Moment of force, first chapter mechanics of first chapter you have read about moment. So suppose एटा गोटे ऑब्जेक्ट अछि बा हमर बॉडी अछि, it is tending to turn about this point, hinge point एटा अछि, मैं एटी फोर्स दे करी, suppose this is p force and this force is acting at a distance of l. So p into l, moment equal to p into l. You have already read this. P into L, suppose O point it अछि, about this point O the body will turn. So this is moment. So here moment of force amnele. Similarly instead of force if you take area into distance then this is called area moment or moment of area. Similarly moment A into, suppose moment A into distance L, this is moment. If you multiply another distance L, this will be area A into L square. So friends, it is moment of inertia na nahi. area into distance रो square. So that's why moment area into distance moment रे ही multiply ହେଲା ଆଉ ଗୋଟେ distance. So moment of moment area रे distance multiply हेले moment of area moment रे distance multiply हेले कोन हबो moment of moment बा हम ताको कहूचे second moment right. So this is another term or another word you can name to moment of inertia. 3 names বা 4 names हम कहि परिया कोन one is moment of inertia, rotary inertia, resistance to rotation, second moment ଆଉ ଗୋଟେ ହେଲା moment of moment. So 5 names जहाँ भी पढ़िबो you will mean the same thing. So केमती बाहर करछे ଗୋଟେ ऑब्जेक्ट रो moment of inertia ना हम जदी मास नउछे मास into distance रो स्क्वायर एरिया नेले एरिया into distance रो स्क्वायर रामर नंबर राम into distance रो स्क्वायर जहार नबो तमे moment of inertia चाहूतबो सेटा into distance रो स्क्वायर राइट. So this is moment of inertia and physical significance है moment of inertia जोगु गोटे बॉडी रो जदी अधिक moment of inertia अछि definitely it will oppose more amount against its rotation. माने जदी रोटरी मोशन करूछि हमकु फोर्स अधिक दरकार करिवो बंद करिया पई बा जदी स्टील अछि माने रेस्ट रो अछि ताको रोटेशन करिया पई भी हमकु अधिक फोर्स right. So suppose just imagine this is a body. We want to find moment of inertia of this body about certain axis. Certain axis means जो axis रे चारि कड़े से बुलिवा को चाहछि. Suppose एटा हली axis L बोली धरो axis टाको. We want to find moment of inertia of this is an irregular figure, irregular object. किछि भी object हे पारे right. So आमे चाहूछे आर moment of inertia बाहर करिया पई about this axis L axis ता बा गोटे लाइन हे पारे पॉइंट हे पारे कोठी भी moment of inertia आमे बाहर करबा जो पॉइंट से टर्न होछि तमे जानि थबो नो हैंड फैन. So the body is rotating about certain axis and you are holding that handle of that axis you are holding. So whenever you rotate the total object will rotate about that axis. So similarly suppose you just imagine that concept it hala gote line जो line रे बा जो axis चारि कड़े ही बुलिबो के ए body टा right. So to find the moment of inertia remember it is not a body because amaro course रे mass moment of inertia nahi amaro area moment of inertia achi. So we are talking about a section jahar area achi mass we are neglecting. So for this आमे कोन करू छै जेमिति सीजी रे करूतले हम गोटे स्मॉल एलिमेंट नबा small element and तार distance count करबा. Let's say तार distance केते अछि y from this axis L right. So our area small area eta small element. So तार area of element को हमें dA बोली धरिबा equal to dA means area of the small element. So element रो moment of inertia about L axis हमें लिखिबा कोन नाइ moment of inertia को short रे mi लिखा जाय. Always you remember mi means moment of inertia. So mi of element की है ना dA area का dA about L axis केते हबो ना this is equal to area हला dA into distance केते ना y. So distance square dA into y square. So this is the moment of this element only. आमे जदी टोटल ऑब्जेक्ट रो बाहर करिया चाहिबा एनो इंटीग्रेशन गोटे फार्मूला अछि. इंटीग्रेशन काहे कि होय इंटीग्रेशन समेशन पाई हुए means a total object is if you consider the total object is consisting of number of elements like this ए भलिया हजार एलिमेंट बा लाख एलिमेंट बा इनफाइनाइट नंबर ऑफ एलिमेंट्स अछि देन गोटी एलिमेंट रो मोमेंट ऑफ इनर्शिया काढिबा ताकू इंटीग्रेशन करिबा within the boundary of this object माने a to a पर्यंत हम एलिमेंट एमति रहउछे. सो a to एलिमेंट कंसीडर करे a पर्यंत गोटे सर्टेन बाउंड्री जोटा कि फिगर को रिप्रेजेंट करिवो करिले हम पाइबा टोटल फिगर रो मोमेंट ऑफ इनर्शिया. सो टोटल मोमेंट ऑफ इनर्शिया mi of plane figure means this figure I am talking will be integration dA into y square by integration रो normal formula हिसाब रे देखियो because multiplication भी commutative so dA टा को पर लेके हम लिखिबे y square dA so moment of inertia एटा l axis रे होची so हम एम लिखंती I stands for moment of inertia l means about x axis l axis is y square dA and y what is y it is important y हला जो एलिमेंट हमें कंसीडर करछे तार डिस्टेंस परपेंडिकुलर डिस्टेंस फ्रॉम दिस l axis so this is y so integration y square dA right so formula already मैं देछि ए स्लाइड रे पर्टिकुलर स्लाइड रे हमें x axis अछि y axis अछि z axis अछि so here we are finding moment of inertia about x axis and friends if you see x axis रो एलिमेंट रो डिस्टेंस केते अछि y so that's why mi of the element dA about x axis केते dA into y square so total figure रो mi about x axis by integration होछि integration y square dA now मु टास्क दोछि तमको कि about y axis केते हबो तमे को mi of the element a total figure about y axis कोन हबो ना समान जिंसो एलिमेंट रो mi बाहर करबा about y axis डिस्टेंस केते अछि एलिमेंट रो डिस्टेंस from y axis x अछि कि नहीं so dA into x square mi about y axis and तार integration that is integration dA into y square or y square sorry x square dA काहे ना dA डिस्टेंस हला y ru x so x square dA y बदला हम जदी x लिखिबा x square dA integration will give you I y that means moment of inertia about y axis so सेटा को हमें कोन लिखिबा ना integration I y will be integration x square dA integration of x square dA टी बोले देखा जाउ नै ठीक रे क्लियरली लिखुछि एठी so similarly same figure रे z axis भी अछि हमें किछि भी about any axis we can find moment of inertia so I y equal to integration of x square dA right यदि हम z बार करिबा I z means about z axis particularly say figure mu एटा को ड्रा करछि so suppose a l axis बदल रे now I am taking x axis already l axis हमें बाहर कर सरछे x axis we already बाहर करछि so this is x axis this is y axis and this is z axis and distance x axis ru y distance y axis ru element रा में small element यदि हम एटा कंसीडर करछे this is the small element right so distance केते अछि x रे and z distance अछि from z axis so y z हबो केते ना z axis ru z distance so integration z square dA right element रो एरिया केते ना dA into z square integration हेले total figure रो about y axis ना y axis रो distance काउंट करिबा जोटा कि x so x square dA integration y x axis रे बाहर कले y axis रे बाहर कले x आ x axis रे बाहर कले ix हम लिखिबा जोटा कि डिस्टेंस अछि y so integration y square dA so here we are finding the mi of this plane figure about x about y about z so any axis रा में बात कर परिबा right so now related to this moment of inertia important theorem गोटे अछि जोटा कि हम कहै perpendicular axis theorem now we'll go to that directly perpendicular axis theorem very important because it is coming regularly in examination bele bele proof bhi ase bele bele khali statement pachare so you should know what is perpendicular axis theorem for mi so this is your perpendicular axis theorem statement and the statement is the theorem of perpendicular axis states that the sum of moment of inertia of a plane figure here it is written area so किछि भी पारे about any or about two mutually perpendicular axes which are coplanar axes is equal to the moment of inertia of the same figure about another axis which is perpendicular to both axes right so carefully read the statement it is very important moment of inertia of a plane figure about two mutually perpendicular axes is equal with moment of inertia of the figure about another axis which is perpendicular to the both axes Means suppose if you consider, so this is the statement already I जानले statement कौन statement हिसाब रे suppose x y and z three axes, x axis, this is y axis and this is z axis. You know x and y are two mutually perpendicular axes. Suppose a figure अच्छी कि हमारे plane figure, right? So now suppose this is the element, small element of the figure, and the distance from y axis हमें कहते हैं इसे x axis to y and z from z axis, right? So we are considering a certain element whose area is dA. So dA equal to area of element, right? And x, y, z are the distances from y axis, x axis and z axis respectively. Means y axis to x distance, x axis to y distance, z axis to z distance रे element रही है. हमें बाहर करीबा total figure रो plane figure जोटा area A about x, y, z बाहर करीबा and prove करीबा बा justify करीबा perpendicular axis theorem. So according to perpendicular axis theorem, moment of inertia for this figure about x axis plus moment of inertia of the same figure about y axis, means x, y dita perpendicular axis already कही से equal होगा केते ना I z z, means moment of inertia of the same figure about z axis. से कहूची कि यदि दीटा mutually perpendicular axis अछंती तार moment of inertia about those two axes add करले third axis कोटे आसीबो जे again perpendicular थियो both two axes को. Means here z axis is perpendicular to both x and y, x y निजे perpendicular, again z is perpendicular to both x and y. That's why if we add Ixx, that is moment of inertia about x axis, plus Iyy, that will be equal to Izz. This is about your perpendicular axis theorem. So now we have to prove this theorem. So proof fine. Now already you know how to find the moment of inertia of this figure about x axis, about y axis. So मते को Ixx कहते हैं moment of inertia about x axis. Now integration, obviously element area into distance square, element area कहते dA, distance कहते x axis y, so y square dA. Similarly I y कहते हैं वो ना I y equal to x square dA का integration. So integration of x square dA. Now according to perpendicular axis theorem, Ixx plus Iyy को add करेगा. So Ixx plus Iyy will be equal with integration y square dA plus integration x square dA, right? Right? So this will be equal to integration x square plus y square dA, right? So friends, if you consider this triangle, this is a right angle triangle, and you know this angle is 90 degree. So if this is y, so obviously this line is parallel to this, so this distance is x, right? So x, this is y and this is z. So x square, it right angle triangle according to Pythagoras law, I am लिखिबा कोन ना x square plus y square, x square plus y square equal to z square according to Pythagoras law. So in place of x square plus y square, now we can replace this x square plus y square to z square. That means the Ixx plus Iyy equal to integration x square plus y square jar के लिखिबी z square. So z square dA. Z square dA. So what is z square dA? And dA into z square, that means moment of inertia of the element about z axis, and तार integration है माने total figure रो moment of inertia about z axis. So this can be written as Izz. So now we have the statement Ixx plus Iyy, which is equal to Izz. Now we have proved this theorem Ixs plus Iyy equal to Izz. Sometimes polar moment of inertia bahar kara jay. What is polar moment of inertia? Suppose if you consider this blackboard or whiteboard, this is x axis, this is y axis. So these two axes are lying on the board. But what about z axis? Z axis is perpendicular to the board. So whenever we are finding moment of inertia about an axis which is perpendicular to the figure, then we can say that moment of inertia as polar moment of inertia. So Izz is nothing but same thing, means moment of inertia about z axis which is perpendicular to both x and y, but figure को perpendicular अछि. So that's why this is also called polar moment of inertia, right? So anyway, we have proved perpendicular axis theorem. We again कहूची the statement को, because it is very important from exam point of view. The moment of inertia of a plane figure about any two mutually perpendicular axes is equal with moment of inertia of the same figure about another axis which is perpendicular to both axes, right? So now we have completed your moment of inertia concept and perpendicular axis theorem. In the next class we will read about parallel axis theorem. Friends, it is important. Very important, because exam re either statement as 2 marks, then statement and proof asila, then 5 marks, right? Eta alternate year re asuchi. Jodi ebe statement asichi, next year definitely statement and proof asibo. So ebe jodi statement and proof asi, next year re khali statement asibo. But it is very important, vital be settify, right? So we have completed this class. If you will have some doubt, again and again dekho, still doubt hoile, you can mail us through our doubt clearing mail ID, right? Thank you.